Voyager 1 detects the brightest explosion ever recorded in space. Did you know it takes more than 22 hours for a signal from Earth to reach Voyager 1? Since their launch in 1977, the two Voyager probes have traveled billions of kilometers from the Sun, venturing into deep interstellar space. Over time, these aging spacecraft have revealed astonishing insights about our cosmic neighborhood. But recently, Voyager 1 sent back data so powerful and mysterious that it immediately caught the attention of scientists around the world. Something extraordinary had happened, something we still don't fully understand. Stay with us until the end to discover what Voyager 1 recorded in the depths of space and the cosmic mystery it set in motion. The mind-bending distance of Voyager 1. Space is unimaginably vast. The average distance between the Earth and the Sun is about 150 million kilometers. Yet Voyager 1 has now traveled more than 25 billion kilometers from our home planet. Only one other human-made object, Voyager 2, has reached a comparable distance, about 20 billion kilometers away from the Sun. What makes their journey even more remarkable is that neither probe was originally designed for deep space. They were built to last just 10 years and study the outer planets. But here they are, nearly 50 years later, still transmitting data from beyond the edge of the solar system. Despite their outdated technology, Voyagers store mission data on magnetic tape with a total capacity of just 536 megabits. They've achieved what no smartphone, no satellite, and no other spacecraft has: crossing into interstellar space. Entering interstellar space. On August 25, 2012, Voyager 1 made history by becoming the first spacecraft to leave the heliosphere, the bubble-like region influenced by the Sun's magnetic field and solar wind, and officially enter interstellar space. Voyager 2 followed on November 5, 2018. These milestones gave scientists a unique chance to study how our Sun interacts with the space between stars. One key finding: the heliosphere is much more symmetrical than previously thought, more spherical than stretched or lopsided. Another discovery involved the behavior of plasma. Voyager 1 experienced turbulence in plasma after crossing the heliopause, the boundary of the heliosphere, suggesting a thick and unstable transition zone. In contrast, Voyager 2 found the region to be thin and stable. The reason? Timing. Voyager 1 crossed during a solar minimum, while Voyager 2 entered during a period of high solar activity. The Sun's influence on this boundary appears more significant than we ever imagined. The magnetic shield and hidden forces. Voyager 2 also confirmed that a strong magnetic wall exists on our side of the heliopause, an additional layer of defense against cosmic radiation. This magnetic shield is thought to form from currents carried by the Sun's magnetic field, weakening and peeling off near the edge of the heliosphere. Interestingly, the interstellar magnetic field outside the heliosphere turned out to be 2 to 3 times stronger than expected. As a result, interstellar particles apply up to 10 times more pressure on our solar boundary than previously assumed. Despite these breakthroughs, interstellar space remains largely a mystery. The entire system is dynamic, vast, and has only been explored at 2 points, where Voyager 1 and 2 exited. The Voyager missions are nearing their end. As incredible as their journey has been, the Voyager missions are nearing their final chapter. Technical problems and occasional loss of contact are now common. NASA recently had to reactivate long-dormant thrusters on Voyager 1 just to keep it going. To conserve power, the spacecraft are on strict energy-saving routines. Only 3 of their original 10 instruments are still operating. Fortunately, one of them is the plasma sensor, and in late 2022, it recorded something extraordinary, a signal that shook the cosmos. On October 9, 2022, while Voyager 1 was cruising through deep space at around 61,000 kilometers per hour, its instruments suddenly detected a massive surge of high-energy radiation. Just 19 hours later, the same burst reached Earth. The cause? The most powerful gamma-ray burst ever recorded, an event so intense that it outshined all previously known explosions of its kind. Named GRB 2-21009A, this gamma-ray burst was 70 times stronger than anything ever detected. It released more energy in seconds than our sun will emit over its entire 10 billion-year lifetime. The radiation was so extreme that it blinded gamma-ray detectors around the world and triggered measurable changes in Earth's ionosphere. Even more astonishing, the explosion occurred over 2 billion light-years away. The brightest of all time, BOAT. Because of its sheer magnitude, the event was quickly dubbed BOAT, an acronym for brightest of all time. Scientists believe that such an intense burst might only reach Earth once every 10,000 years. But what caused it? Initially, astronomers suspected it was a long-duration gamma-ray burst from a collapsing massive star, a supernova. Yet, oddly, none of the usual supernova signs were visible at first. The afterglow was so bright that it overwhelmed any subtle clues for months. It wasn't until the afterglow finally dimmed that NASA used the James Webb Space Telescope's near-infrared spectrometer, NIR-SPEC, to examine the site. The verdict? It was caused by a supernova, but not an especially powerful one. A narrow beam of cosmic energy. So how could a relatively normal supernova produce such an extreme burst of radiation? Astronomers now think it's all about the shape. When a fast-spinning star collapses, it can create narrow jets of particles that shoot into space at nearly the speed of light. If Earth happens to lie directly in the path of one of these beams, the gamma-ray burst we detect becomes far more intense. In the case of BOAT, it was one of the narrowest beams ever observed, laser-focused and pointed right at us. That narrowness likely explains the extreme brightness, but scientists also believe other, still unknown factors may have been involved. As with many cosmic mysteries, full answers may take years to uncover. Voyager 1, now nearly 50 years into its mission, has once again reminded us just how much there is left to discover in the universe. From mapping the edge of the solar system to catching the brightest cosmic explosion ever seen, these aging probes continue to push the boundaries of human knowledge. And the best part? They're still going.